We're really looking forward to this week spent with Dr. Martin Entz. He is a research scientist at the University of Manitoba, and he'll be telling us this morning a little bit about his research project that he's been working on for over 25 years, allowing farming practices to evolve along lines that are more in tune with nature, and that is something that's very interesting to us as a people, as a community here at CMU. So we're really looking forward to this. Just a little bit about Martin. Among many things that he does, he owns a little farm out in Lebo, 40 acres, which is shared by several families. One of the things that allowed it to grow was a little book club that his wife was in. They were reading a book called The Omnivore's Dilemma, and the ladies said, "Do you think Martin would let us use his farm?" And one of the things that they do now is use it as a family farm, and of course he helps them along. Shady Maple Lane Shared Family Farm. We're really looking forward to it. Thank you, Martin, for being here with us. Please.
Okay, thanks. What a great crowd. My grandmother would be very proud of me because she always wanted one of her many grandchildren to go to a Bible college, and I have to say none of us did. So today this is for her. So the picture in the, not that we weren't interested, but it just never happened. So I'm really pleased to be here. The Science in Residence program is, I think, terrific. I think the size of this crowd really shows me that it's something that you're interested in, and I think it's wonderful. I'm going to get right into my talk because we're going to spend a few days together. But today I've titled this "Journey into Natural Systems Agriculture." And if you look at the picture behind me, there's a farmer walking in a field. What is this crop that is growing in this field? Put up your hand if you want to answer the question. Okay, you. What is this? Canola. Okay, so you come up and get your door prize, please. So there's door prizes. I have just to keep you alert. And if people don't remember anything about the lecture, they'll remember that there's ball caps involved. Okay, so this is canola, and really our hope is that farmers will be walking through this canola field sort of for a while yet, but by the end of this person's farming career, hopefully they'll be walking into that forest and practice agriculture in a different way that's more natural. I'm going to start off today just giving you some sort of reasons for why I think that's important. And then I'm going to proceed from there. Now, just to jump right into why I want these farmers to change, and that is because we have some serious problems. Let's deal with our problems first. 2015 was the year of soil. The United Nations Food and Agriculture Organization called it the year of the soil, and it's really important because globally we are losing soil at twice the rate that new soil is being formed. This is a satellite photograph of Madagascar, an island off of eastern Africa, and you can see the red soil coming off the rivers and then moving into the Indian Ocean. You can all see that? Right, it's pretty obvious. And this is a problem around the world. I've had the opportunity to work in northwest China in the Loess Plateau, which is an area the size of France, where the Chinese government is really doing almost an entire ecological restoration because the degradation of the soil has been so serious. So soil loss remains probably our number one problem in thinking about the sustainability of our agricultural system. And the other issue is water. I could have talked about fresh water because there are certainly no shortage of challenges in terms of fresh water, in terms of the aquifers around the world that are used to irrigate crops, whether they be in northern China or the central US or in India. But I wanted to alert you to the dead zones in the oceans. By the way, I see some of you taking notes. I'm going to leave my PowerPoints for whoever, to Tim, and he can distribute them to anybody who wants them. But in the oceans, there are these really dangerous trends happening related to agriculture. Dead zones are areas that have no oxygen, and when nutrients from poor sewage management in cities and also agriculture flow into the oceans, there's an elevation of the nutrients, they use up the oxygen, and the fish die. And there's 400 dead zones in the ocean right now. The largest one is on the Baltic Sea, and the picture on the lower right is actually the Gulf of Mexico and a very large dead zone where the Gulf of the Mississippi River runs into the Gulf, and so no fish can live there. And this is already agriculture is challenged, and we're now really hurting our fishery. So another thing to keep in mind, and the third bit of stark news, sorry, that really has motivated us, my team and I at the University of Manitoba, to take a different approach, and that is to think about energy. We're using a lot of energy to grow crops. It's still not that much. I think we use more energy driving recreational vehicles around the world than we are using in manufacturing nitrogen fertilizer. But so we're all in this. But when we think about agriculture, we want a high efficiency. And this shows different agricultural products and how much energy we get out per every unit of energy going in. And you can see in Manitoba, if you look at the second to last row, we're doing well. We're at about 8-to-1 on most of the prairies. But some of the crops are actually consuming more energy than they're producing. So we have to think about energy. So just to summarize that sort of tough news, when we think about what sort of job one, well, it's soil, it's water, it's energy, and of course, I didn't mention it, but it's biodiversity. We've heard a lot about bees, but the diversity on Earth is very important to a functioning agricultural system. Of course, it's very important to the functioning of us as human beings. So how to get the message out there? Well, I thought, I don't know, do you ever procrastinate and watch Netflix? Probably never. Who's never done that? You get a hat if you've never done that. Okay, probably somebody over 60. Who doesn't, procrastinate? Okay. Nobody. Okay, you all watch Netflix. So I thought, well, why not make a Netflix series out of this? And I'm calling it Journey into Natural Systems Agriculture. And the season opener is going to be a little dull, but people will be interested enough that they'll hang in there. So I'm calling it Going Back to School, right? So I just want to show you what I would include in that season opener, and that is a couple of lessons from people who are wise. And the first one is this is a book that I read in my 4th year of university, and it's really stayed with me. I thought it was written by a hippie or something. Ends up it was written, and I didn't learn this much later, I forgot. It was written by an industrialist. E.F. Schumacher was the chief economic advisor to the British Coal Board for 27 years. He was an industrialist, and he wrote this book, Small is Beautiful. And the book talks about how, big corporate approaches to things are not really very wise. And this is what he says in the book. He says, the exclusion of wisdom from economics, science, and technology is something that we could get away with for a while we were relatively unsuccessful. And I think the way I interpret that is if we all have little patches of land that we farm and we mess some of them up, we're not messing the whole thing up. But he says now that we have become very successful, the problem of spiritual and moral tradition moves into the central position. And this is something that should really speak to you here. But are we successful? We are well, depending on how you define success, but agriculture procures 40% of global photosynthesis, okay? The thing that, happens in the leaves or in the algae is used for humans. So we are highly successful. And so he reminds us that we need to have spiritual and moral traditions in our thinking. The second teacher that I really have admired has been dead even longer. This is Stanley Jevons, and wrote a book in 1865 called The Coal Question. And he was asking why it is that at a time when steam engines were becoming more efficient in England, that coal consumption, instead of going down, was actually going up. And so the short answer is efficiency leads to more consumption. What was happening with coal is that as we were having more efficient motors, we would free up capital, and that capital would go out and find some other fossil fuel to burn. That's kind of how our economy has worked for 200 years. And so when we see this piece of farm machinery, and yes, I mean, I would love to drive that piece of farm machinery and watch a sunset. It's fun. But, you know, we have to rethink how we define efficiency. How many of you have heard of Stanley Jevons? Anybody heard of him? Okay, you really have heard of him? You get a hat. Come on up, or you can come collect it later. Okay, so there's your hat. Okay, I didn't want to give one to a professor. I was trying to avoid that, but oh well. He's an economist. So what we've done in our work is we're working on what we call level 3 conversion to sustainable agriculture very, very quickly. What we spend a lot of time doing is sort of level 1 stuff. We try to increase the efficiency of conventional practices. Number 2, we substitute some inputs for other things, so maybe we use a herbicide instead of tillage, and there is some value to that, or maybe if you're an organic farmer, you use herbicides or a cover crop instead of a herbicide. But what we're doing in our lab is we've decided it's time to redesign the system. And so we're redesigning it so it functions on the basis of a new set of ecological relationships. And that picture of a field there, that's our Glenley long-term study where we actually do a lot of our work. And I started that soon after I started at the U of M in 1992. And when, you know, I always have to defend my program to my colleagues and my dean. They're always like, this is nostalgia, Martin. It's, you know, I say, no, it's not, you know. And so we've really worked hard to be very scientific. And we've worked at the molecular level. In that long-term study, we've DNA fingerprinted the bacteria in those systems. We've worked at the cellular level, and we've also worked at the landscape and the farm level. So, and this is just a picture of some of my graduate students that I've had the good fortune of working with. Okay, the next, I'm almost done season opener. You know, you're probably done your popcorn. You're wondering, when is this thing going to end? Next lesson, really important, all adaptation is local. What happens in Honduras doesn't happen in Brandon, Manitoba. What happens in India is different than what happens in many different places in Africa. So it's just an important thing for us to remember, because we have, in our technological world, we have this notion that we're going to, you know, do something in a city somewhere and the benefits are going to cascade everywhere. And sometimes that happens. But if you're working in the ecosphere, it's different everywhere. So all adaptation is local. And the final one, and how many of you have heard of North Face clothing? Okay, you've all heard of that, right? Who's never heard of it? Okay. Okay, you never heard? Okay, come and get a hat. Come and get a hat. You can see, like, clearly one of my goals is to get rid of these hats so I can relax. And okay, thank you very much. And North Face is, you know, very popular clothing brand. Congratulations for just, you know, being an individual and not buying into the. But this guy, he started North Face Clothing, Doug Tompkins, and he sold his company since, and he does a lot of conservation work in South Africa, in South America. And one of the things that I really like, I've heard him and interacted with him through a network, and he really talks about how technology shapes society. And I want to return to the issue of energy to kind of illustrate that point. And I'm just borrowing right from Doug Tompkins' thinking. He says, let's take a look at what society you need for different types of different technologies. So if we compare nuclear energy with wind energy, and you look at the column in the center, it shows us the energy efficiency, how much energy we get out for every investment of energy going in. And they're in the same ballpark. Nuclear is, you know, 3 to 1 to 10 to 1, it's in that range, and wind is about 8 to 1. So they're in the same ballpark. But he illustrates that the society that we need to get there is very different. If you have nuclear energy, you need, first of all, lots of money. You need a big army, so people come and take it from you. You need a lot of scientists, and you only need so many of those, right? if you have wind energy, especially if you have small-scale wind energy, you don't need an army. You get the picture. And I think it's really important to look at, even in our context in Canada, if we look at the tar sands, it's only a 5-to-1 efficiency. It takes us actually 1 unit of energy to get 5 units out. That's very inefficient energy, and it has other challenges. So whether, I'm not slamming the tar sands, I'm concerned about them, but I think technology shapes our society, and we have to be very careful. So that's episode 1. It really sort of frames some of that historical thinking. Episode 2, now we're getting into some racy stuff. The bacteria-atmosphere affair. Very fun. Okay. What's that all about? Well, this really emphasizes the fact that 78% of the air that you breathe right now is nitrogen. And this is actually where we spend a lot of our energy in agriculture, is using high pressure and heat to fix the nitrogen that's naturally in the atmosphere and make it into nitrogen fertilizer pellets or anhydrous ammonia. But plants can do this naturally, and so can many other, plants do this. Bacteria actually associate with the plants to do this, and so you have this affair between the bacteria that live in those nodules of that soybean plant there and the atmosphere. So that's where the affair comes in. And it's really useful, and it's really exciting. We've been working with conservation agriculture programs in mainly in Southern Africa, Eastern Africa, and we were brought into this work because of our long history of working with legumes. And so this picture is actually one of our field trials in Zimbabwe, and you can see there's not only corn or maize, there's also legume growing in between there. And unfortunately, the extension services of many countries did not emphasize intercropping with legumes for a generation of farmers. So even though it's an indigenous practice, it virtually doesn't happen in many, many places. So trying to reintroduce this affair into the conservation agriculture. And it really makes a difference, because the farmers not only wait until the legume is completely mature to harvest the seeds and then make something with them, they also take the leaves off of those plants. So looking back, maybe not yet, but in about 2 weeks, those little, this picture was just taken last week. Those little cowpea leaves will be ready for plucking, and then this is what you are served. Some of you may have had various starch relish mixtures wherever you are. The starch is called something different in many different countries, but it's you hear of carbs and protein, right? Well, the sudza. Is the white stuff, is the carbs, that's maize, and the leaves are the protein. So they're very important. It's very exciting work to be involved in. And we didn't have to look too far to see this. The First Nations, who way before Treaty 1 was signed, they were doing this 1,000 years ago in this part of the world. This is actually a field of legume and maize and pumpkin or squash this is what the Mandan used to do in places like the Souris River Valley. So people have been doing this for a long time. We're just back to the future on this. Okay, episode 3, which is the healthy strawberry? Can you tell? So that's what we're calling it, strawberry fields. This is goofy, right? This Netflix thing. Yeah, well, it's what I'm going with. I'm not going to change it now. Okay, so here we are. We're asking the question, the strawberries look the same, but can we produce, can they be different? And Lynn Carpenter Boggs at Washington State has done a lot of work on especially grapes and strawberries and looking at organic and conventional production. And she's interested in the soil functional genes, and so we've also participated in a little bit of that. But I wanted to show you just one little data set from her work that was published in a PLOS One journal, which is a pretty good journal. It's pretty hard to get published in there. The antioxidants and the phenolics, these are called secondary plant metabolites for anybody who cares. Very few. Anybody care about that? Okay, you care about that? Okay, come get your hat. Okay, thank goodness I can get rid of my last hat. Now I can relax. Okay, good. You care about secondary plant metabolites, and they're higher in these organic crops, and the reason is really what's happening with the relationship between the plant and the soil. The soil in these organic systems, they're not always better. Organic systems can sometimes be pretty bad, but if they're managed really well, they can be really good. And there's a whole bunch of lively things happening in the soil which switches on genes in plants and causes expression of better outcomes. And it's very exciting. And so the statistics students, you get it? The p-value there on the right? Okay, Tim will explain that later if you haven't gotten that. Okay, so in preparation, that means they're statistically significantly different. So in preparation for episode 4, what do they call them? The executive producer decided to learn how deep roots of prairie plants actually grow. Okay, so this is a picture, if you can see it, that was published in 1919. And it was Weaver, who was an ecologist from Nebraska, and he was fascinated to learn how deep the roots of different prairie plants would actually grow. And so you can see they're very deep. Who's from Alberta? Okay, so wild rose, right? There's the prairie rose. That's your provincial flower plant. And look at it, it roots 7 meters down. So in all those pastures in Alberta that contain prairie rose, you're bringing all these minerals and nutrients from down 7 meters below the soil up into the surface. And so this is how the prairie evolved such rich soils. So then they decided to name episode 4, Where's the Beef? I'm so happy that you find this amusing. Makes me feel a lot better. So Burger Queen is asking the question, where's the beef? Is it on the perennial prairie, or is it in the feedlot where we used, a little short-rooted monoculture annual crop to grow the feed? No bias there, right? And so, because Burger Queen knows that there are advantages ecologically to having livestock graze perennial plants, and in some cases even the native rangelands, which were there to begin with. So not only is grazing on these perennials, this herbaceous material, better for the ecosystem, it's also better for you as the consumer of animal products, whether you eat milk or cheese or meat. The omega-6, omega-3 ratio, that's, there's good fatty acids and bad fatty acids, good cholesterol, bad cholesterol. How many of you shot a deer before and eaten venison? Somebody must have. Okay, it's good, and it's very good meat, and it's got an omega-6, omega-3 ratio, unless it was raised on grain in the forest behind the building here. It's got a ratio of 1 to 1. That's what we evolved with as human beings over millennia. Now that we're grain feeding our animals, we've got that ratio out of whack, and so it's not very healthy to eat those animal products. But if those animals are raised on herbaceous forages, we've got a much better, much healthier fat. And you start hearing about that. You even see pasture butter now available in the summer. And so that's part of that story. So thank you, Burger Queen, for pointing that out to us. We think this will be a very popular episode. Okay. All right. I think this is the second to last episode. This is brought to you by Home Depot. It's called Do It Yourself. And this is a project that I'm really excited about, that we've been carrying out since 2011 in response to farmers losing intellectual property rights over their seeds. So we've been doing an organic crop breeding program for about 12 years, but we took it one step further, and that Anne on the upper left there, she's one of our project directors. She makes the crosses. So we actually have farmers coming to us and we say, what parental material would you like? And we're working with potatoes, with wheat, and with oats, and a little bit with corn. And they say, well, we like this. Our miller, our buyer wants this. We're only working with organic farmers. And so we make the crosses for those farmers and then give those seeds to the farmers. And the crosses are made up on the top right here. You've got your boy plant and your girl plant, and how it goes. So what we do is This is the group of farmers that we're working with. Last year we had 51 farmers from Vancouver Island to Prince Edward Island, and the red is wheat, the blue is oats, and the green is potato. And so, like I was saying, what we do is we give the seeds to the farmers, and what we do on your left, we give them about 7,000 seeds per population. And from that, they select about 300 or 400 seed heads, or panicles in the case of oats. It's a bit different for potato. And so they are doing selection for 3 years. And then after that, we bring their stuff back into a replicated experiment to see how they've done. And they do very well. This is just a little snapshot of some of the data from the study. We were looking at farmer-selected and conventional checks. Conventional checks are sort of the standard varieties, and farmer-selected are the things that came off these farms. And if we average them, the farmer-selected lines had higher zinc, higher iron, and higher manganese. Zinc is super important for brain development, and it is lacking in some of our diets. And while you can supplement these things with vitamins, I'm told that it's much more effective to have them in a whole food source, but I'm not an expert in that area. So this is quite exciting. The farmer-selected ones also yield as well, or actually better, especially in their local conditions. So we're just in the process of, we're in year, this is about the 4th year we've done this, and it's one of the most exciting projects that I've ever been involved in, because we're not only getting the farmers involved, but we're then being able to scientifically evaluate what improvement they made, or how they impacted these populations. And why would these farmer-selected varieties have greater zinc? It's because they selected them under conditions that were not heavily endowed with fertilizers and other things. The plants kind of had to work this out for themselves using things like mycorrhizal infections. I'll talk a little bit about that on Wednesday, or we could talk about that at lunch. And so those mycorrhiza can help get these micronutrients. How many of you have ever wondered how an evergreen can grow on a rock in the Canadian Shield? Anybody? I wish I had more hats. I'd give you more hats, but pretend you have it. Steal it from somebody else. No, we're not allowed to do that. So no, we won't do that. It's because of fungi. It's the fungi that allow those trees to actually bring those nutrients out of those rocks. And the same thing happens in agricultural soils, and I think that's what's happening here. Okay, the final episode is, you can see that bus, and it says Green Acres on it. And I'm saying here, next stop is Green Acres. And I want to talk just for a moment about urban agriculture, because I think there's as much lawn in the U.S. as there is wheat acres. Some people think that's terrible and disgusting, but if you flip that around, you say, well, look at all that food production potential in the suburbs. And landscape architects and even agronomists are starting to write and model how suburban neighborhoods like the one on your right can actually be used for food production. And we're seeing that. We're seeing that happen. I think you're seeing that happen right here at your university. But there's a tremendous potential not only to produce food, but to create community. Because in the suburbs, nobody goes outside. Everybody's inside all the time, and unless you're walking your dog. And so I think there's lots of potential. I've been to a number of communities where this has happened, and it also creates business opportunities. It creates community opportunities, reduces our energy footprint of producing our crop. And maybe we can learn to make peace with each other. Speaking of energy, I wanted to make a point about that, since I forgot earlier, but I learned that the Iraq War, the carbon footprint of the Iraq War since 2007 was about the same as everybody in the United Kingdom flying to Hong Kong and back at least once, 1 to 4 times. So anywhere we can make peace, it's good for the environment. Okay, so I had 25 minutes. I think my 25 minutes are up. I just wanted to wish you well on your journey into natural systems agriculture, and I think there'll probably be some time for questions or discussion, if you have any.
Yeah, we have about 5 minutes. If anyone has questions, just step up to the mic.
Why didn't you bring more hats? That's a good question. Does anybody have any comments or questions? How many of you like cattle? Anybody here really like? Okay, then for you, I'll show you this picture because I took it out because in the interest of time. Let me just tell you a story since there's not a burning question. When we're going to have these animals on these grass, like Burger Queen told us we should. This is really a fascinating area of research, and it's very applied as well. There's animal scientists who are trying to find out what are the things that allow an animal to finish on grass, like no grain at all, nothing. And then there's these farmers. There's farmers all over the place doing this, but these are two local examples. Stefan and John Bow. They're just east of Winnipeg. And they have a bull business, and they breed animals that are specifically going to finish on grass. And they're really different looking animals. They have very short, little stubby front feet and big rumens to just process all this stuff. So if any of you like animals, there's a lot of fun here. So anyways, just a little add-on. There's got to be a comment or question, or you can disagree with something I said. That'd be fine. Or you can just go for a lot. Yeah, yes. Yeah. Yeah. The reason the grass-fed is so popular is because of the fatty acid profile. The butter that would be grass-fed would have an omega-6 to omega-3 ratio closer to 1. And once we're eating a lot of food higher than 6 or 7, there's a lot of coronary problems that go along with that. So, the New Zealanders have figured this out, and they have a very grass-based livestock industry. And so, I would always choose that butter or the pasture butter that's around here over there. So the reason is the fatty acid profile. Yeah, yeah.
I was just curious how this is received in the wider community at U of M. Like if you've had conversations with the egg program there, or what's going on. I was just kind of curious about that.
Great question. Well, I'm in the ag program. I'm a full professor in the agricultural and food sciences faculty, and early on, I was tolerated. I remember my department head once said, well, that Glenlee study you have, Martin, it's not really research, but it is attracting some attention, so that's good. Well, it is great research. We've published all kinds of papers off there in extremely good journals. And the way that I've done it is to publish as much as I can so that our scientific integrity is high, and the quantity and quality of our output, because it's competitive. So that's I'm not bragging. I'm just saying that's a strategy that you have to use. I know other people at other universities who've really taken a different approach to agriculture and food, and if they're not publishing, it's easy to sideline them. So that's one thing we've done. Number 2 is I've had great graduate students. Like I only want graduate students who want to change the world. Like if you just want to come and get a better job, fine, go work with that person or that person. And I've had students from all over the place, and it's been wonderful. It's been a blessing to have these students. I've had over 42 of my own graduate students. That's been a big part of it, because they sometimes bring their own, money. But in terms of, we still don't use the word organic in our faculty. We don't do that. So you're still a bit of an outsider, but that's okay. I don't mind. But I'm certainly supported, and as much as anybody else is. And it's changing. It's changing through I can even see, I teach in the diploma program as well, the 2-year diploma program, and I teach an organic course, and there's about 30 students and 20 to 30 students in that course every year. And the attitude among those students has really changed. In the last 10 years, I've taught the course for about 14 years now, and the last, 6-7 years, the students are more interested. So the change is coming through the students. What we have to do is allow the students to have a voice, so they can push for that change. Yeah, so it's a long answer, and not a really great one, but we can talk later too.
Our time is up, so let's thank Martin again. Thank you so much. I'll just take a couple of announcements. just a couple of announcements before we leave. Number one, there is a free lunch available for any students who want to continue this conversation with Martin right now in the conference room at the end of the hall. Number two, tomorrow's chapel is Martin speaking about land as gift, a game changer, and then on Wednesday evening will be the public lecture at 7 p.m. in the Marpeck. Thank you everyone for coming. Have a great day.